Whoops, guys. So I guess I got cut off from that last video. So we're going to be looking at how do you write equations of lines if you've been given slope and 1 point. So now we're starting to look at how things kind of can work on the algebraic end. So if you've been given the slope, so for example in this one, if you've been given that the slope is equal to 2 and that you have a point or a coordinate at 2, 3, that would mean that you have a coordinate for the x and the y value for that. So we can use the slope and the coordinate in order to figure out what is our y-intercept so that we can come up with the equation for the line. So we already know that since it is a slope of 2, that it's going to fit into y is equal to mx plus b, or your slope-intercept form is what we call this, okay? Unless the slope is undefined or a zero slope, then we know it's going to fit into that format. So I'm going to use all of that information to say, okay, well, we know that it's going to fit into y is equal to mx plus b format. And I do know that my slope is equal to 2, so I'm going to fill in my slope to be 2. And I know that an x coordinate, or an x value that can be found on this line, is at 2. So I'm going to say times 2 plus b, and that my y value is equal to 3. So now I have 3 is equal to 2 times 2 plus b. Now I can use that information to isolate b. And so I'm going to say 2 times 2 is going to give me a value of 4. 3 is equal to 4, subtract 4, and I'm left with negative 1 is equal to b, or my y-intercept. So now I know y is equal to mx plus b, and I know that y is equal to, and my slope is equal to 2x, and then minus 1. And so the equation of that line that has a slope of 2, and it's going through the point 2, 3, would look like 2x minus 1. Now, if I wanted to double check it, I could come down here and I could graph it and say, okay, well, if I know that it's going through the point 2, 3, I'm going to graph that point 2, 3. And then I'm going to say, well, I know it has a slope of 2, meaning that if the slope is 2, that means that my change in y divided by my change in x means that it's going up 2 and to the right 1, up 2 and to the right 1. So I'm going to go ahead and graph that. And going up 2 and to the right 1 is the same thing as going down 2 and to the left 1, down 2 and to the left 1. And so if you continue graphing that line, you should be able to see that your y-intercept there is sitting at negative 1. So hence, where that equation came from, y is equal to 2x minus 1. So your y-intercept was at negative 1. All right, so let's try another one. So example number 14. So example number 14, I know right off the bat that since my slope is something other than 0 or undefined, that the equation is going to fit into that format of y is equal to mx plus b. I'm going to use the information that they've given us to say, all right, well, I know that the slope is equal to 1/2. I know that an x value that can be found on that particular graph is a value of 4, getting it from my coordinate, plus b is equal to my y value, which is equal to a value of negative 3. Well, 1/2 times a value of 4 is going to give me 2. 2 plus b is equal to a value of negative 3. I'm going to subtract 2, and I just found out that my y-intercept is equal to b. So if I'm looking for the equation of that line, it's going to look like y is equal to 1/2 x minus 5. Now, if you wanted to graph this one, or any of these for that matter, you should be able to graph it and see that, in fact, that the y-intercept would have been at negative 5. All right, so let's graph it and see. So I've got a point at 4, negative 3. So 1, 2, 3, 4, negative 3. And then I've got a slope of 1/2, meaning I'm going up 1 and to the right 2, up 1 and to the right 2, or that's the same thing as going down 1 and to the left 2, down 1 and to the left 2, down 1 and to the left 2. And so if you see, when I graph that equation, you should be able to see that that y-intercept right there is at negative 5, or it's the equation of the line y is equal to 1/2 x minus 5. All right, so we can continue that trend for each and every one of these. All right, so let's try a couple of more. All right, so example number 15. So that should have said m is equal to negative 2. M is equal to negative 2. So again, I know that the slope is something other than 0 or 1 or 0 or undefined. So I know it's going to fit into y is equal to mx plus b format. I'm going to fill in the pieces of the puzzle that I know. So my y value is equal to 3. My slope is equal to a value of negative 2. My x value is equal to a negative 5 plus b. So that's going to give me a value of 10 plus b is equal to a value of 3. Subtract 10, and I'm left with negative 7 is equal to my y-intercept. So if I were going to come up with my equation for that line, it would look like y is equal to negative 2x minus 7. All right, and if I were to graph it, it would match up perfectly. Okay, all right, so out of these, I'd like for you to try examples 16 and 17, 18, and 19 on your own. okay? But I am going to go ahead and look at example 20 with you. So example 20, hopefully you look at and you're like, oh, okay, so the slope is undefined. So that means it's not going to fit into that y is equal to mx plus b format. And anytime you're confused as to if it's going to be an x is equal to something graph or a y is equal to something graph, you could just draw a quick sketch of it and say, okay, well, here's the coordinate 2, 6, 5, 6. Here's the coordinate. And if it's undefined, you should say, okay, well, I know that it's going to look something like that particular line. And so if you were to sit here and choose any of those, oh, not the point 3, 6. I drew 2, 6 instead of 3, 6. There's 3, 6. We'll just add another increment. So there's the coordinate 3, 6. And then let's say that I choose any of these other ones. Well, that would be the coordinate 3, 3. And then this would be the coordinate 3, negative 1. And you could continue that pattern to notice that your x values are always equal to 3. So this would be the line x is equal to 3. And that's what the equation of the line would look like. Okay? All right. So the next ones are the last scenario that I'm giving you is probably some of the trickiest parts of this. Okay, so we're just kind of taking what we just looked at and we're going one step further. Okay, so in this scenario, we are trying to figure out how do you write the equation of the line if I've given you 2 points. So you don't know the slope and you don't know the y-intercept. All you know about that line is that it crosses through those 2 points. Okay. So right off the bat, if we were going to graph it, we could likely figure out the y-intercept, but there are going in the slope of it, and hence we could come up with the equation. But later on, there's going to be scenarios where we're not going to be able to look at a graph and figure out what the equation of the line would be, because it might be that they are fractional numbers and that they're not nice, easy whole numbers to figure out the slope or the y-intercept for. So we're going to start with friendly numbers, and we're going to double check it with a graph, and that way we can start to build up some of our algebraic fluency so that later on we can figure this out algebraically without relying on a graph every time. All right, so today we're going to start to talk about this idea of a slope formula and trying to figure out what the slope of a line is if we've only been given 2 points. Okay, so remember that slope can be figured out or determined by your change in y values divided by your change in x values. Okay, and so we're going to look at these as if this is a first coordinate and a second coordinate. We've been given 2 coordinates, and we know that in each one of these categories, in each one of these coordinates, this represents an x coordinate and this represents a y coordinate. I'm going to label them as x sub 1 and y sub 1, or x1, y1, so that I know that those are the x and y coordinates for my first coordinate that I'm referring to. And I'm going to label my second coordinate x2, y2, all right, so that I know that we are talking about our second coordinate. Now, the next steps are, I'm going to look at the difference between my y values divided by the difference in my x values. So what I mean by that is I'm going to say, what is my y2 value minus my y1 value? What's the difference between those two? How far of a change did they have? Divided by how far of a change did my x values experience? Okay, and I'm going to look at those as a ratio. And now I'm going to substitute those values in just as I see them. So 5 minus 3. So I took the 5 minus 3, or y2 minus y1. 5 minus 3 divided by my x2 minus my x1, or 4 minus 2. And then I'm going to simplify it. So that's going to simplify to 2 over 2, or that's the same thing as saying 1 over 1. So we just figured out that our slope is equal to 1. All right, so I now have my slope. I now know that my slope is something other than 0 or undefined, so I know it's going to fit into that y is equal to mx plus b slope-intercept form. And so I can use one of those coordinates and my slope together to figure out what the equation of the line is. So I can kind of refer back to that last scenario that I gave you. And I can say, okay, well, I know it's going to fit into y is equal to mx plus b. I'm going to choose this second coordinate to kind of work with. So I'm going to use the coordinate 4, 5, but you could use any coordinate. And I'm going to say, okay, well, that represented an x. This represented a y. I now know my slope, and I can say, okay, well, y is equal to 5 is equal to my slope, which is a value of 1, times my x value, which is equal to a value of 4, plus b. And I can say, okay, well, 4 plus b is equal to a value of 5, subtract 4, and 1 is equal to my y-intercept. And so now I have my slope, I have my y-intercept, and now I can build my equation to say y is equal to mx plus b. But now I know that my slope is equal to 1x and my y-intercept is equal to 1, or I could say that the equation is just y is equal to x plus 1. All right, so now I'm going to look at this on a graph so that we can double check our math and just to make sure that you guys can kind of see where did all of those numbers come from in the first place. All right, so let's kind of back this up. Hopefully you guys can see that okay. All right, so remember, we're going to go ahead and graph those 2 points. And so I've got the coordinate 2, 3, and I've got the coordinate 4, 5. All right, and so between those 2 coordinates right there, hopefully you're able to see that if we're comparing our change in y, so remember how far up or down we're going up a value of 2, and we're going right a value of 2. Okay, that's where that up 2 and to the right 2 came from over here. All we did was take the difference between those 2. So our difference in our y's, we went up 2, and our difference in our x values, we went to the right 2. But you could also see that going up 1 and to the right 1 is the same thing as going up 2 and to the left 2. And so hopefully you can see that that is why that slope of 2 over 2 is the same thing as the slope of 1 over 1. All right, and so if we were to end up graphing that and to continue that pattern over and over, hopefully you should see that, all right, well, it's crossing at a y-intercept of 1, and so the equation of that line was y is equal to x plus 1. All right, so let's try another one. All right, let's look at example number 22. All right, so example 22, we're going to start with that same process, and we're going to say, okay, well, I know that this is a first coordinate, this is second coordinate. I'm going to label this x1, y1. I'm going to label this x2, y2, and I'm going to say, okay, well, I know that slope represents my change in y divided by my change in x. It's a ratio from one to the other. And I'm going to say, okay, well, my difference between my y values, how far up or down I went, was a value of 15 minus 3, and then a negative 4 minus 2. And then I'm going to simplify it. Well, negative 15 minus 12, or minus 3 gives me a value of 12. And negative 4 minus 2 is going to give me a value of negative 6. And then if I simplify that, that's going to give me a value of negative 2 over 1. Right? So hopefully you should be able to see, okay, well, the slope of that line is equal to a value of negative 2. All right, so there's our slope. Next, I'm going to use the slope in one of those points to figure out what the y-intercept is. So I'm going to say, okay, well, I know the slope is something other than 0 or undefined, so I know it's going to fit into that y is equal to mx plus b format. I'm going to say y is equal to mx plus b, and I'm just going to use this first coordinate now. And I'm going to say, okay, well, my y value is a value of 3, is equal to my slope that I just figured out is a value of negative 2, times my x value, which is a value of 2, plus b. Negative 2 times 2 is going to give me a value of negative 4 plus b. And if I go to isolate b, I'm going to say add 4, and that's going to give me a value of 7 is equal to b. So now I know my slope, I know my y-intercept, and so I could then say y is equal to negative 2x plus 7 would be the equation of that line. All right. So what I would like for you to do is I'd like for you to then try example 23, 24, and 25 using that same process. And then we'll see how things go. All right. Hopefully this helps you on your IXL assignments that are assigned for this week. And I hope you get really, really, really good at practicing this, and we'll see you soon. Bye, guys.